Kiran from Sri Venkateswara College of Engineering, Bengaluru. Today I am gonna explain one of the topic in discrete mathematical structure, that is basic connectivities and truth table. Let's move on to introduction to basic connectivities and truth table in discrete mathematical structures, that is DMS. These are the fundamental concepts in discrete mathematics. They are used to represent logical relationship and evaluate the truth value of logical expressions. Understanding these concepts is essential for solving problems in computer science and mathematics. This is a truth table. We will gonna understand this truth table. Let's move on to next slide. Logical operators. Logical operators are symbols used to connect propositions in logical expression. The main logical operators are and, or, and not. These operators helps in analyze the relationship between statements and determine their truth values. Table. Truth table is a table used to evaluate the truth values of logical expression. Each row in truth table represents a different combination of truth values for the input proportions. By using truth table, we can systematically determine the truth values of logical expression for all possible input values. In this table we can see zeros, one zeros, so many zeros and 1, where 0 represents the false value and 1 represents the truth value, that is true. Conjugation operator. The conjugation operator is same as the AND operators. This is logical operations. The AND operator denoted by cap, where that is returns the true only if both input proportions are true. The truth table for AND operator show that output is true only when both inputs are true. The AND operator represents the logical operation of conjunction where both conditions must be satisfied for the statement to be true. We can see that table here, P, Q and the P and Q, where we can see true for P and Q. P cap Q is true only if P and Q is true. Rest all P cap Q is false, because where sometimes P as true and but Q as false, sometimes P as false but Q as true. In last both the conditions are false, so this condition cannot apply. If both the P and Q are true, then only the conjunction value will be true. Disjunction operator. This is a OR operator denoted by V, that is reverse to the cap, returns the true if at least one of the input proportion is true. Okay, then truth table for the OR operator shows that output is true when at least one input is true. The OR operator represents the logical operation of disjunction where either condition can be satisfied for the statement to be true. In the table we can see if either one of the P or Q, one of the in those one of is true, then the condition is P or Q is true. We can see here in the AND operator, if the condition like true false, it is false, but here true false, it is true only. Next, for the both, if it is both false, then it will be obviously false. Negation that operator, that is not operator. The not operator denoted by the negation symbol returns the opposite truth value of the input proportion. The truth table for the not operator shows that it flips the truth value of the input. The NOT operator represents the logical operation of negation where the original statement is reversed. P and the negation P. What is the main difference is, if the P is true, then negation P is opposite to the P, that is false. If the P is false, then the negation to the P is true. It is opposite to the given condition. If it is true, it will be false, and if it is false, it will be true. Next, combining logical operators. We can combine the logical operators by the using the logical operations by using braces. Let's see here. Logical operators can be combined to form complex logical expressions. The order of operations follow precedence rules similar to arithmetic operations, where we will follow some precedence set of rules to solve these problems. By using parentheses, we can clarify the order of evaluation of complex expression involving multiple operator. Implication operator. The implication operator denoted by in the arrow mark, it represents if then statement. The truth table for the implication operator shows that if false only when the premise is true and conclusion is false. Implication is fundamental concept, the logical and plays a crucial role in reasoning and problem solving, where they are saying like if this condition is true for all the condition, there is except for one condition, that is if the given condition is, for example, P is true but Q is false, then the P implication Q that is false. We can see in the table here alpha, but for the true, both the true values, it is for A alpha implication beta is true, and then for next we see the alpha is true but beta is false, so that alpha implication beta is false. Only for this condition it is false, rest all it will be true only. Biconditional operator. Biconditional operator denoted by the both arrows moving outside represented if and only if statement. The truth table of the biconditional operator shows that it is a true only when both proportions have same true values. Biconditional statements are used to express logical equivalence between two propositions. This condition saying that if the both the proportions, that is P and Q, which should have the same value, either true for the both, either it should be true or it should be false. Tautology and contradictions. Tautology is a logical expression that is always true regardless of truth values of its input proportions. A contradiction is a logical expression that is always false regardless of truth values of input proportions. Tautology and contradiction are important concepts in logic and can be identified using truth tables. Example, or we have the uh, or symbol and then negation or. For this, we will if we check whether it is a tautology or not, it shows that it is a tautology. De Morgan's law are the rules that describes the relationship between negation and logical operators. The first law states that the negation of a condition is equivalent to the disjunction of negation. The second law states that negation of disjunction is equivalent to the conjunction of the negations. Applications in computer science, basic connectivities and truth table are essential in digital logic design. They are used in design and analysis logic circuits such as gates and flip-flops. Understanding logical operation can and truth tables is crucial for building efficient and reliable digital systems. Application in mathematics. Basic connectivities and truth table are used in mathematical proofs and reasoning. They help mathematical analyze logical representation relationship and derive conclusion based on given premises. In fields such as number theory and graph theory, logical reasoning is essential for solving complex problems. In real-world application, basic connectivities and truth table have practiced applications in fields like AI and robotics. They are used in program decision making, algorithm and control system. Conclusion. These are the truth table fundamental concept in discrete mathematics. These are the foundation for the DMS. They provide a systematic way to evaluate logical expression and analyze relationship between proportions. By mastering these concepts, students can enhance their problem solving skills and develop their deep understanding of logical and reasoning techniques. Thank you for watching this video.